Hello friends, in this video we are going to learn how to convert the flying wedge formula into Fisher formula. Okay, these all are called flying wedge formulas. They can also be called as wedge dash formula or perspective formula. Okay, look at them. This bond, okay, A, C, C, B. These two bonds are on the paper, but these two are called wedge bonds and they are away from the paper. The dotted wedge, this is behind the paper and this one is before the paper. I mean this one is projecting towards a viewer. Okay, the dark wedge is projecting towards a viewer. Okay, so all the formulas all are flying wedge only. The condition is the bonds on the paper, okay, bonds on the plane of paper, they should be adjacent to each other. You see, these two are adjacent to each other and there should not be any wedge bonds in between them. That is a condition. You see, these two are adjacent and no wedge bond in between them. Wedge bonds are this side, but here there's nothing. And here also you see, they are adjacent and no wedge bonds in between them. So this is a way of writing the flying wedge representation. And let's see these drawings. You see, the previous one was one chiral center. Here there are two chiral centers. Okay, so these bonds, this bond on the paper, and they are adjacent, and this bond on the paper and they are adjacent. Okay, so if we look at the structure, if we look at the bonds on the paper, so because the bonds on the paper is the key here. Here you see the bond on the paper, it is like this, isn't it? It goes this way, this way, this way. Okay, it is like this, just like a stool. Okay, the furniture stool. And look at this one, this one, this one, this one. Okay, it is like this is also like a stool, but it is tilted one. And look at this one, it goes like this way. It looks like a chair. Okay, and see this one. Okay, this way, this way, this way. This is also a chair. Okay, so if we look at the first two, this chair conformations, okay, this chair, I'm sorry, the stool like bonds, they are eclipsed. Remember, they are eclipse conformation. They represent, okay, the eclipse conformation. If we get the bonds on the paper, okay, like a stool, you can understand that the molecule, its conformation is eclipse conformation. And look at this one, these two, the chair-like bonds, they represent staggered conformation. This you need to remember first. Okay, cup means stools means eclipsed, chair means staggered. That you need to remember. Okay, that's very important. From there only we are going to proceed. Okay, and the point is these eclipsed, this is all right, because if we want to convert anything into Fisher projection is only meant for eclipsed conformation. You can't write the staggered conformation into Fisher projection. If we want Fisher, you need to have it eclipsed. Fisher is only for eclipsed. Okay, so this is eclipsed, so this can be converted into Fisher. This is also eclipsed. This can be written as Fisher, but still it has to be slightly changed for our convenience. It should be changed this way. Okay, the tilted stool can be, okay, turned upside down to get like this. Okay, normal stools, so that from these two you can go to Fisher, and here also Fisher you can write. And how about these two? You see, this bond is like this, but this bond is upside down. Just bring it down. Okay, turn it, rotate it to 180 degree, you can get the stools. Here, this is all right, this is all right, this one, turn it. Okay, now you can convert everything into fixture projection. Okay, so after writing this way, you need to view from this side, this way. Okay, this also. Okay. View from the top, you will get the fixture projection. Very easy. So at present, you remember, you need to see the bonds on the paper. In the flying wedge representation, see the bonds on the paper and see whether it is like a stool or like a chair. If it is like a stool, it represents that the conformation is eclipsed. If it is like a chair, it represents that the conformation is staggered. Convert the staggered into eclipsed, convert the chair into stool, you can convert that, you can write it that into fixture projection easily. Okay, so stool to fixture, that is the only point. Make everything into a stool like conformation, then you can write it in fixture. Okay, now let's see this. Yeah, look at this, this is already correct. Okay, so you need to view from here, from the top. So let me rewrite again the same thing. Let me rewrite CO2H, CO2H, OH, again H, and here OH, again H. Okay. Now, as I said, view this from the top. From here you have to view it. If you view this, write it. Straight away, CO2H, CO2H. I mean the bond on the paper. Okay, I mean the stool. Okay, one end carboxylic acid, other end carboxylic acid. You wrote it, and since you're viewing from the top, from this side, okay, from this side you're viewing, so what will you get on your right? OH here for this carbon, and here also OH, because both are front projecting towards the viewer. So since you see from here, it will be on your right side, so it came on the right side, so the remaining two on the left. Okay, so this is the fixture projection. You got it. So what did you do? You had the stools, you viewed from the top, whatever is on your right, put it on the right side. Okay, that is fixture projection. And how about this one? This one, the stool is upside down. This is also stool, okay, but upside down. Okay, the stool is this way, so you need to convert it into this way. Okay, this is staggered, this is eclipsed, both are eclipsed. Now, just for convenience, make it like this. So since you have rotated it to 180 degree, because it is upward, here it is downward, so 180 degree you rotate it. Then how about these wedge bonds? Since you rotated 180 degree, means the front will go back, back will come front. That means here, okay, CO2H, here also CO2H, that's okay, and OH front, it will go to back. Here OH front, it will go to back. Here H back, it will come to front, because you rotated 180 degree, 180 degree. And here you see H back, and it will come to the front. OH at the back, it will go to the OH at the front, it will go to the back. Okay, now you can write it into fixture, because you are viewing from here. What will you get? Just write it. Write this CO2H on your stool. So what, since you're viewing from here, what will be on your right? H will be on your right, so that the OH will be at their left. And here, H will be on your right, OH will be at your left. And let's come to this one. This one is slightly different. Here this structure is what? Chair. That means, you see, this one. So it is a staggered conformation. So you need to change it, convert it into eclipsed. For that you rotate this bond, so that you will have this one. Since you rotate this bond, now you get the eclipse conformation, a stool conformation. So now this bond you didn't do anything, so it remains as such. OH at the front, H at the back, no problem. And this one you rotated, this carbon you rotated. So 180-degree rotated, this upward, here it comes downwards, CO to H, CO to H, okay, downwards. So 180-degree rotation means this front will go back, back will come to the front. OH at the front, it goes back, since 180-degree rotation. H at the back, it will come to the front. Now draw the fixture projection. Draw the fixture projection. Since you view from here, what is there on your right? Let me finish the CO to H. CO to H, okay. What is on your right? H. Here what is on your right? OH. Write the remaining. OH at your back, H at your back. Okay, so you got the fixture. And how about here? You see this? Here the bond on the paper, here I get the chair. Okay, so this bond let me rotate, so that since I rotate means I will get the stool. If I rotate, what will happen? I didn't rotate, this one is all right, so let me write as it is. CO to H, CO to H. This side I didn't rotate, isn't it? So it remains as such. OH back, front, H at the back. This is all right. Only this bond I rotated. Okay. CO to H above, I have brought it down. So what happens? OH at the front, it goes to the back side. H at the back side, it comes to the front side. Now okay, view it from here. CO to H, CO to H. What is on your right? OH. Here what is on your right? H. Write the remaining thing. H left, OH at the left. Now we got the Fisher projection for all these four structures. Okay. Thing is, you need to see the bonds on the paper. That is a key. Whether the bonds on the paper, it looks like a stool or it looks like a chair. If it is a chair, it is staggered. If it is a stool, it is eclipsed. If it is a stool, okay, straight away you can convert it into fixture. If it is a chair, you have to convert it into a stool. I mean, staggered should be converted into eclipsed, then write it in fixture projection. Okay, so this is the idea. And for the staggered, again, there is one more shortcut formula, you remember, for staggered alone, only for the staggered. Okay, only for the staggered, there is another shortcut formula. The point is, see this, OH front, only the wedge bonds you see. Here OH is front, the other carbon H is at the back. Here front OH, H back. And if we come to the eclipse, they both will be at the same side. You see H and OH same side. Okay, OH front, H back. Since they are here the front, there at back means they will be on one side in eclipsed. In the staggered formula, remember, in the staggered formula, staggered conformation, the groups that are opposite will be at the same side in fixture projection. Okay, in flying wedge, if the groups that are opposite will be on the same side in fixture projection. That is why OH, H opposite, but here they both are on the same side. Very important. You don't have to convert all these things, eclipsed chair into stool, then fish chair. These are all and all not needed. Straight away see the, if it is eclipsed, sorry, if it is staggered, only for staggered, not for these structures, only for this chair. Okay. See whether it is chair, whether it is staggered. If it is staggered, if it is a chair shape, see the bonds whether they are opposite or same side. The opposite bonds will be at the same side when you come to the fixture. Here OH, H opposite, they are on the same side. Okay, that is what you need to remember. Now here is a question in 2017 TRD. Yeah. Predict, look at this. Predict from the following which is erythro-enantiomer. They need only erythro. Erythro means what? Same group, same site. Okay, that is erythro. See, for example, if I have H, okay, let there be anything CHO, CH2OH, OH, OH. Okay, this is called erythros. That means H are same side, OH are same side, erythros. If the other way, H here, OH, again OH, H. Here opposite, then that is trios. Okay, so erythro means same side, same group, same side. Trios means opposite side. Okay, so the question here is which one is erythro? Which one is erythro-enantiomer? That is a question. So look at this. What is this? Chair or stool? This is a chair. Here you see chair, because we have to see the bonds only on the paper. So this is a chair. Here this is also a chair. This is also a chair. That means all the four structures are staggered conformations. So staggered means, I told you just now, the last trick I told you, if it is staggered, see the wedge bonds, and the bonds that are opposite are the same side in the fixture projection. You see here the first one, A. H is back, H is front. That means they are the same side when you go to fixture. Here they are opposite and they will be same side when you go to the fixture. And here you see H is back, here also H is back. That means both are at the opposite side. Here you see H is back, H is front. So opposite. That means they are at the same side when you go for fixture. Here you see H is back, H is also back. That means they both are opposite side. Understand? If they are opposite in staggered, they will be at the same side in eclipsed. So here they are opposite, so they are same side. Here they are same side, both are back side, so they are opposite here. Okay. Now look at this. H same side, this is erythro. Here H same side, this is erythro. And these two are trios, H opposite. So option A, option C, these are erythro conformations, erythroisomers. Okay. Option A and C. Where is it? A and C. Okay, this one. C is the answer. A and C. Okay. Hope you understand. And let me tell you one more thing. With that, let me close this topic. Okay. See this. You would have seen this sort of drawing. Okay. OH, OH. What is it? What is it? Syndiol. Diol. Is it a syndiol? So this can also be written this way, isn't it? So H is front, sorry, OH is front means H is back. Here OH is front, that means H is back. Now you've got the flying wedge. Can you convert it into fixture? Yes. What is the shape? This one is a chair, isn't it? This one is a chair. Chair. You got a chair. That means from here you convert it into a stool. From this you can go for fixture. Okay, so very easy. This sort of drawing also you can arrive the fixture projection very easily. Okay, hope you understand everything. If you have any queries, please write it in the comment box, and I'm happy to answer your questions. Okay, wish you all the best. Thank you very much, and we'll meet in the next video. Thank you.